The scientific method is a logical, step-by-step procedure for solving a problem. There are a number of specific steps that need to be followed in order to execute the scientific method properly. Step 1 involves defining the problem. In this case, you would ask a very specific question that would guide your experimentation so that you can find an answer to your question. As an example, we will use the work of Francesco Redi. He's an Italian scientist who lived in the 1600s. Buongiorno. My name is Francesco Redi. In the time of Francesco Redi, people thought that living things could come from non-living things. For example, maggots, which are small worm-like bugs, could come from decaying meat. This idea is known as spontaneous generation. Redi knew that that was not true. It just couldn't be. So he decided to test this idea with an experiment. So he started the scientific method by defining his problem. The question that he asked was, do maggots come from decaying meat? And obviously today we know that they don't, but in this time frame, they had to do an experiment to figure it out. Step 2 of the scientific method involves gathering information or doing research. You might go on the internet and do some research on a reputable web page in order to find information to answer your question. But in Francesco Redi's time, he couldn't really go on the internet. So he might have to do some reading or perhaps go out into the field and do his own research. He doubted that something alive could come from something dead. He looked around in his environment and noticed, well, horses come from other horses, cows come from other cows, birds come from other birds, and people come from other people. So how could maggots possibly come from something dead, like decaying meat? So based on this information that he gathered from his surroundings and his direct observation, he decided that spontaneous generation could definitely not be the answer to this question. So he was going to design an experiment in order to answer that question. Where do they come from? Step 3 of the scientific method is forming a hypothesis. A hypothesis is a possible solution to your question. In Redi's case, his question was, do maggots come from decaying meat? Well, he had noticed, based on his research, that living things come from other living things of the same kind. So he would hypothesize that maggots come from eggs laid by flies, not from decaying meat. But rather than just phrase the question like this, we'll put it in an if-then format. So, as far as Redi is concerned, if maggots come from flies and not decaying meat, then meat that is covered should produce no maggots. This gives him a good outline for designing an experiment to answer his question. Step 4 is when you actually test your hypothesis by conducting an experiment. In Redi's case, he set up 2 jars. Both had pieces of decaying meat inside. The only difference between the jars is that one had a cover and the other did not. The one with no cover would attract flies to the meat. So each of these 2 groups are referred to as an experimental group and a control group. In this case, the experimental group is the jar that has no lid and allows flies to get to the meat. An experimental group only has one variable that is different from your control group. In this case, the flies, which can get to the meat. The control group, which is the jar that has the lid, is used as a comparison. It does not allow the flies to get to the meat. This way, Francesco Redi would be able to discern whether or not the maggots in the meat were coming from the flies or from the meat. Ha-ha! This will prove that I'm right. Step 5 of the scientific method involves making and recording observations. There are two major types of data: qualitative data and quantitative data. Qualitative data involve using one or more of your senses to describe the quality of the group. So you might use your sight, your hearing, your sense of taste, touch, or smell. For quantitative data, you are using a tool to measure or quantify something. So you would be using some sort of instrument in order to measure your data in this case. This type of data is numbers. In the case of Redi's experiment with the two jars, some of the qualitative data, after finding the results, could be the color of the meat, the smell of the meat, or the texture of the meat. These are all descriptions that would use words to describe the data that results from the experiment. For quantitative data, he could use a thermometer to measure the temperature inside the jar. He could use a balance to measure the mass of the meat. He could count the number of flies, or he could count the number of maggots. All of this information would be recorded as a number and is considered quantitative data. In this case, the data that Redi was interested in was whether or not there were maggots in the meat at the end of the experiment. And what he happened to see in this case was that there were maggots only in the experimental group, not in the control group that had the cover on the jar. Aha! I knew spontaneous generation was not correct. Step 6 of the scientific method involves analyzing the data to find information that either supports or goes against your hypothesis. In Redi's experiment with the jars and the meat, he was looking to see if maggots come from decaying meat or if they come from flies. The relevant data here is the number of maggots at the end of the experiment. That's an example of quantitative data. Quantitative data is oftentimes represented in a table. Maybe Redi's table might have looked like this. He might have had 5 jars that were open and 5 jars that had a cover to keep the flies out. He would count the number of maggots in the open jar and count the number of maggots in the covered jar and record his data. This is some sample data that Redi might have found during his experiment. As you can see, there are a number of maggots in each of the experimental groups and 0 maggots in the control group, which was the jar with the cover. Redi might have conducted averages for each group. The average number of maggots in the open jar in this case was 22, whereas the average number of maggots in the covered jar was 0. In step 7 of the scientific method, you draw your conclusions. This is when you decide whether your data supports or disproves your hypothesis. In the case of Reddy's experiment, his data supported the idea that maggots do not come from decaying meat, but rather from some other element in the environment, for example, the flies. Based on this information, we can come to the conclusion that maggots do not come from decaying meat. Therefore, the idea of spontaneous generation was false. The final step of the scientific method involves communicating your findings to the scientific community. This would involve writing a formal lab report and having it published in a scientific journal. In Reddy's case, he would communicate the fact that spontaneous generation was false. Bravo! My hypothesis was correct.